Hi, in this video we will see the multiple choice questions from chapter 2 polynomials from class 10 mathematics. So let's go to the first question. In the graph of polynomial p of x is shown the number of zeros of p of x's. So in this question we have to find the zeros of the given polynomial. Okay, a graph is given. Based on this graph we have to find the number of zeros that the polynomial has. Okay, so first we have to identify the function variable in this. In this case, the polynomial is in the terms of x. So the function variable is x. So we have to check the number of times the line crosses the x-axis. So that will be equal to the number of zeros. Okay. Here it crosses 1, 2, 3. 3 times. The number of zeros will be 3. In case the function variable is y, if the given polynomial is in the terms of y, we have to count the number of times it crosses the y-axis. But in this case, the given polynomial is in the function of x, so we have to count the number of times it crosses or touches the x-axis. Okay, so for this type of question, you have to be careful to determine the which one is function variable and which axis you have to count. In this question, the function variable is x, so I have counted the number of times it crosses or it touches the x-axis. So the answer is 3. Let's go to the second question. The graph of a polynomial p of x cuts the x-axis at 3 points and touches it at 2 other points. Okay. Here the given polynomial p of x crosses the x-axis at 3 times at 3 points and touches it at 2 other points. So the total number of zeros will be the number of times it crosses plus number of times it touches. So 3 plus 2 will be 5. Okay. The answer is option C. The next one, which of the following would be the graph of the polynomial x minus 2 whole square into x plus 1. So 4 graphs are given and the polynomial equation is given. We have to find the which among these 4 represents the correct graph of the given polynomial. To find that, we have to first find the roots of the given polynomial. Okay, so let us write the polynomial here. We have x minus 2 whole square into x plus 1 is equal to 0. Okay, now we can split this into 2 terms. We will get x minus 2 into x minus 2 and again we have x plus 1. Okay, here we have 2 in the power, so I split this into 2 terms. X plus 1 remains same as it is. Okay, now we can equate these 3 terms individually to 0, so we get the root value. So the first we can equate the first one. We will get x minus 2 is equal to 0. This one is x minus 2 is equal to 0. We can take the 2 to the minus 2 to the right side, so that will become plus 2. So we will get x is equal to 2. If you equate the second term, you will get the same answer. X minus 2 is equal to 0. Again you can take the 2 to the right side, we will get 2 again. Okay, and the third one, x plus 1 is equal to 0. Here we will get x is equal to minus 1. Now we have the 3 roots. Out of those, 2 roots are exactly same. X is equal to 2, so we have to consider it only once, and here we have x is equal to minus 1. Let us take the option A. Here the line crosses exactly at x is equal to minus 2 and x is equal to plus 1. So it is not matching with our answer. So this is not the correct option. Let us take the second one. Here also it crosses at x is equal to minus 2 and x is equal to 1. So this is not also our answer. Let us take the third one. Here we have x is equal to minus 1. It crosses x is equal to minus 1 and x is equal to plus 2. Option C satisfies our answer, but we cannot conclude that option C is our answer. We have to check the option D also. Here also you can see the curve crosses at x is equal to minus 1 and x is equal to 2. Now you can notice that both option C and option D satisfies our root value, but only one among them is correct. You may know that whenever we have 2 equal roots like x is equal to 2 here, the graph does not cross the axis at that point. It just touches the axis at x is equal to 2 and moves back to the same quadrant again. It does not cross to the another quadrant. So by considering this, Option C is correct because the graph does not crosses to the another quadrant at x is equal to 2, but in option D it crosses to the next quadrant at x is equal to 2. So option C is correct. Let us go to the question number 4. The quadratic polynomial whose sum and product of zeros are 5 and 8 are respectively. We have to find the quadratic equation. Sum and the zeros and product of the zeros are given. So the formula for the general form of quadratic equation is P of x is equal to k into x square minus sum of the roots times x plus product of the roots. This is the general form of quadratic equation. Now here the sum value is 5 and the product value is 8. Just substitute the value here, we will get k into x square. In the given question the sum value is 5, so we have to put 5x. Instead of the sum we can put 5x, and instead of this product 8, instead of this product we can put 8 here. Okay, so the required polynomial is P of x is equal to k into x square minus 5x plus 8. Option C. Question number 5. If x minus 1 is a factor of the polynomial and one more equation is given, a plus b is equal to 4. A polynomial equation and additional equation is given, a linear additional equation is given. Then the values of a and b are, we have to find the values of a, b. Here a polynomial equation is given, p of x is equal to x cube plus ax square plus 2b. Okay, and one more equation is given, that is a plus b is equal to 4, and one factor of the polynomials is also given, x minus 1. Okay, now we have to find the value of a and b with the help of these three given data. To solve this question, first we have to find the one root of the polynomial using the given factor. Okay, here the given factor is x minus 1. To find the root from the factor, we have to equate the given factor to 0. So we will get x is equal to plus 1. Now you can use this value in the given polynomial equation and we can equate that to 0, because every 0 of the polynomial satisfies the given polynomial equation and makes it to 0. So we can write the given equation as p of 1. Instead of this x we can put x is equal to 1. So we will get 1 cube plus a into 1 square plus 2b. Okay, it is given in the question x minus 1 is a factor, which means if you substitute the value of x in the given polynomial, its entire equation will become 0. That is given in the question. So we can equate it to 0. We will get 1 cube is 1, a into 1 square is a, plus 2b will be here. Now you can take the 1 to this side, this will become minus 1 is equal to a plus 2b. Okay, this is equation number 2 and we can take this value as equation 1. Now we can solve these two equations using elimination method or substitution method. Whatever it is convenient to you, we can use that equations. Okay, the first one, let us write the first equation, a plus b is equal to 4, and the second equation, a plus 2b equal to minus 1. Here I have to eliminate any one of the two variables, either a or either b. I have to eliminate. Okay, so to do that I am subtracting the equation 2 from equation 1. So I am just putting the negative sign. I am changing the sign of the second equation. Now you can, a minus a will be 0 and b minus 2b will be minus b, and 4 minus 1 will be, actually the 4 plus 1 will be 5. Okay, so we will get b is equal to minus 5. Here you have minus b is equal to 5, which implies b is equal to minus 5. Now we know the value of b, we can use it in any of these two equations to find the value of a. So I am going to use it in the first equation. So a plus b is equal to 4. Let's put the value of b here. Instead of b we can put minus 5 here. We will get an equation like this, and you can take the minus 5 to the right side. So we will get 4 plus 5, a value is 9. Okay, so the value of a is 9 and value of b is minus 5. So the option 9 and minus 5, option B. Okay. Here the question number 6. If alpha and beta are the two zeros of the quadratic polynomial p of x is equal to x square minus k plus x, 6 into x plus 2k into 2k minus 1, then the value of k is, there is a condition is given, alpha plus beta is equal to 1 by 2 alpha beta. Okay. So first we have to find the value of alpha plus beta and 1 by 2 alpha plus beta. The given polynomial equation is p of x is equal to x square minus k plus 6 into x plus 2 into 2k minus 1. This is what the given polynomial equation, and the given condition is alpha plus beta is equal to 1 by 2 alpha into beta. Now we can compare this with the general form of the quadratic equation. The general form is nothing but x square minus sum of the roots, nothing but alpha plus beta x plus product of the roots, that is alpha beta. Now we can compare these two equations to find the value of alpha plus beta and alpha beta. You can check the equation here. The coefficient of x here is alpha plus beta. Here the coefficient of x is k plus 6. So the value of alpha plus beta is k plus 6. Also in the place of alpha beta we have 2 into 2k minus 1, which implies the value of alpha into beta is 2 into 2k minus 1. Now we have the value of alpha plus beta and alpha beta. We can use these two values in the given condition. We will find the answer. Instead of this alpha plus beta, we can put the k plus 6 here. So we will get k plus 6 is equal to 1 by 2. Instead of this alpha beta, we can write the given value here, 2 into 2k minus 1. We will get 2 into, we can write 2 into 2k minus 1. Okay. Now we found the value of alpha beta and alpha plus beta and substitute those values in the given equation. From this equation we have to find the value of k. Now we can cancel these two 2's and we will be left with k plus 6 is equal to 2k minus 1. Our goal is to find the value of k, so we can rearrange the terms which contains k on one side and the terms without k on the another side. So let me take this k to the right side and minus 1 to the left side. So we will get this k will become minus k and minus 1 will become plus 1. Okay. Now 1 plus 6 is 7 and 7 is equal to 2k minus k is k. The value of k is 7. Next, identify the polynomial whose zeros are 1 by 3 and minus 3 by 4. So two roots are given. We have to find the polynomial which satisfies the given two zeros. Okay. So let us take one root as alpha, that is 1 by 3, and another root as beta, that is minus 3 by 4. From this we can find the sum of the roots and product of the roots. Here the sum of the roots will be alpha plus beta. We just have to add them together. We will get 1 by 3 minus 3 by 4. Here the base is not same, so we can do the cross multiplication or we can take LCM. Whatever it is convenient to you, you can do that. Okay. So I am doing cross multiplication. 4 minus 9 divided by 12. So I will get minus 5 by 12. That is alpha plus beta value. And I have to find the alpha beta value also. And that is, we can directly multiply the alpha value and beta value. The alpha value is 1 by 3 and beta value is minus 3 by 4. You can cancel 3 and 3. So you will get minus 1 by 4. Now you know the value of alpha beta and alpha plus beta. We know the general form of polynomial. So quadratic polynomial, p of x is equal to k times x square minus alpha plus beta, that is sum of the root times x plus product of the roots alpha beta. We know the value, right? We know the value of alpha plus beta, that is minus 5 by 12, and the value of alpha beta is minus 1 by 4. We can substitute these two values in the general form. We will get the polynomial equation. Here we have x square minus alpha plus beta value is minus 5 by 12, x plus alpha beta value is minus 1 by 4. Okay. This is our required quadratic equation, but this is not in the option, so we have to convert this into the form which is in the option. Okay, to do that, first we have to simplify this equation. So k into x square, these two minus will become plus, we will get 5 by 12x, sorry, this will be minus 4 minus 1 by 4. Here we have two numbers in the denominators. If you take LCM of these two, you will get 12 as answer. Okay, the LCM of 12 and 4 is 12. Now we can multiply and divide the entire equation with 12 by 12, so that we can eliminate the terms in the denominator. We will get the answer as per the question. So I am just multiplying and dividing with the LCM value that I got in the previous step. Okay. Now we can take the 12 in the numerator inside the bracket and multiply the each and every term inside the bracket. So we will get k into 1 by 12, 12 into x square will be 12x square, and we will get 5 into 12x by 12, and here minus 1 by 4 into 12. Okay, now you can cancel the 12 with 12, and 4 3s are 12. Here you will have 3. Okay, and we can rewrite this equation as k by 12, 12x square plus 5x minus 3. Okay, we just ignore the constant term in front of the equation. Now we are left with the polynomial equation 12x square plus 5x minus 3, which is an option B. If p and q are the zeros of the polynomial 4y square minus 4y plus 1, what is the value of 1 by p plus 1 by q plus pq? Okay, a polynomial equation is given and its zeros are p and q. Usually we will use the term alpha and beta for the roots. Here we have given p and q as roots, so we have to use that one. Let us write the given polynomial equation. 4y square minus 4y plus 1. We can compare this with the general form of quadratic equation, ay square plus by plus c. Here the value of a is 4 and value of b is minus 4 and value of c is 1. As per the question, p and q are the zeros of the polynomial. As per the question, p and q are given as the zeros of the polynomial. Now we can write the formula for sum of the zeros. Sum of the zeros, which is nothing but p plus q, because p and q are the zeros. Here we are going to find the sum, so I am adding them together. So p plus q is equal to minus b by a. That is the formula. The value of b is minus 4. Already a minus is in the equation. Those two will become plus 4, and a value is also 4. So minus into minus will be plus 4, and already a 4 is there. So 4 plus 4, 4 by 4 value is 1. Okay. Next we have to find the product of the zeros. Product of zeros, that is nothing but p into q. Its formula is c by a. The value of c is 1 and value of a is 4, that is 1 by 4. Now we have the two values. The product of the zeros is 1 by 4 and the sum of the zeros is 1. Now let us take the second equation given to us. Okay, so 1 by p plus 1 by q into pq. Here we have only the value of p plus q and pq. So we have to convert this equation in terms of p plus q and pq. To do that, I am going to do the cross multiplication for the first two terms. So q into 1 will be q plus p into 1 will be p. Again p into q will be pq. The third term pq stays as it is. Okay. Now we have the p plus q, pq and pq. Here we have the value of p plus q as 1. So instead of this we can put 1 and value of pq as 1 by 4. Value of pq is 1 by 4. Here also the value of pq is 1 by 4. So 1 divided by 1 by 4 will be 4 and this will be 1 by 4. Okay. Now you can do the cross multiplication. You will get 4 into 4 is 16 plus 1 divided by 4 into 1. If you have nothing in the denominator, you can assume there is 1 in the denominator. First you have to multiply 4 into 4 is 16 and 1 into 1 is 1 and 1 into 4 is 4. You will get 17 by 4 as the answer. So the option is D.